found a mill on Kijiji in February of 2024, and it was a pretty good deal. It was an hour and a half away from me, and I decided to go take a look, and it was in good shape, so I went back to get it. Now I'm on a budget, so I rented a U-Haul trailer for, I think it was 40 bucks per day, and went up and got this 3,500 pound mill. It took me 2.5 hours to get home because of the icy road conditions. I should have covered the mill to keep the salt spray off of it, but didn't even think about it at the time. The gentleman that I bought it from had a forklift to load the trailer, and when I got home, my brother-in-law arranged a forklift to unload the trailer. Otherwise, I don't think I would have been able to do it. The mill is just super heavy. The mill comes with a 5 horsepower 600 volt motor that I need to swap to 240 volt for residential use. A pulley shaft has to be made to adapt the new motor to the mill, and that's what this video is about. The motor has been removed, and we're going to take apart the pulley assembly here. Some jigs were made up to do this, and the circlip was starting to come loose from the shaft. I picked up a suitable motor off of Kijiji for $50 that will be used in conjunction with a VFD to simplify the wiring. So here we're going to remove the moving section of the pulley from the shaft, but there's a burr left from the spinning circlip, so I'm just going to file that down. It still wouldn't come off, so I thought I'll heat it, expand it a bit, but I didn't know at the time that there was a plastic key in there, and it basically made it harder to remove. I think the key might have melted slightly. So now the pulley's finally off, and we know why the circlip was spinning, and that's because the plastic key is sheared in half, allowing the pulley to just spin independently of the shaft. And that could be a reason why he was selling it, but I wasn't even concerned. Like, I heard it run with no load, but probably under some type of load might start making a squealing noise or something. But I wasn't concerned because I knew I was going to change the motor and I had to do some machining anyway. So I'm still grateful for getting a good deal on the mill. So I'm just going to measure the shaft for the deflection here, the original one, and it comes to about 2/1000 of an inch at the end here. And I got to take a bunch of measurements to make a highly detailed blueprint. The design will be two pieces, a shaft with a coupling to attach to the motor, and I'm going to press fit the coupling to the shaft. Now the shaft I used is just, I think it's like some kind of standard shafting that probably around a grade 5 or something like that. I don't know too much about that sort of metallurgy or whatever, and the shaft that's on the original motor is really hard. You can tell when you're filing it. So I'm going to drill a hole in the middle and have a grease fitting that I can just put a small amount of grease in there to help with the wear of the shaft, because I'm kind of concerned it's not going to be hard like the original. So I didn't cut this right to dimension, and it's hard to cut one thou on a pass, so I had to sand it to dimension, which is kind of better anyway because the surface finish is really good. And here we're just gonna cut the bearing step. So here we're going to get rid of the circlip for the pulley assembly. I don't like there's a lot of spring tension that thing holds, and that's why I cut like a 1/8 groove into the shaft. I'm going to use a split washer, kind of like a keeper on an engine valve, and I'm just going to put 2 halves in there, and the collar, the spring collar will hold the two halves from coming apart. So here I'm just going to double check the measurement of this cutoff tool because I need to make the split washer exactly the right width, and just to keep it tight in the groove. And I like just to shout out to Tom at Ox Tool Co. Check out his channel for this carriage gauge idea, which basically is so handy. I don't even need to buy a DRO. It works so good. So thanks for that idea, Tom. Well, using a dial indicator for a DRO to find the center of the shaft is a pain in the ass. The machine's vibrating and the needle's moving around, so you just kind of you know where the center is, but it's all moving. I use table stops here to cut the keyways. That way you don't have to think about the back and forth. You can just think about the depth, and it makes it a lot easier. There's like 3 keyways that have to be done here. I use stops for every single one. So here the slot's being widened to the dimension necessary. It's always, in my opinion, it's always better to cut a keyway with a smaller diameter cutter than you need, and then widen it on both sides equally to the desired dimension. It makes it nice and straight. You don't get any wandering from the end mill or anything. So this is where I'm drilling the grease passage into the center of the shaft, and it's in the keyway so that the key will be lubricated first, sliding up and down when you change the speed. So here we're going to split the washer with a slitting saw. I don't know what it is about these slitting saws. I've made a few arbors now, but it's like they don't cut 360 degrees around. It's like only half the teeth contact. I don't know why that is, but it just seems like every time I cut, half the teeth are contacting. Just a small pet peeve of mine. Oops, there it is. So here we're just going to swap the 3-jaw to the 4-jaw so that the coupling can be dialed in exactly for concentricity and balance, and the hole is going to be bored out for a nice snug slip fit to the motor shaft. Now the pulley shaft coupling end is machined larger because I'm going to do a shrink fit on it, and I got those numbers from the machinery's handbook for a medium shrink fit. I don't think it was the lightest or the heaviest, it was like a medium, and I haven't done that before, so see how that goes. So we're just broaching the coupling now with a 1/4-inch broach that I borrowed. So thanks for that, Pete. I got to raise this bed because I only have a limited amount of stroke here. It's a 10-ton Canadian Tire press. Works alright. Alright, so we have this oven heated up to around 450, and I put the part in there. I think I let it soak for an hour, getting ready to press it onto the shaft. And we're going good until now. That's the full 10 tons that the press can supply. We're not against the shoulder on the shaft. And I reheated it and did all kinds of stuff. Took it to work, used a 20-ton, didn't budge it. And I thought, okay, well maybe we can use it like that. It's only with, 3/8 of an inch from the shoulder. And there it is after multiple heating and pressing attempts. So the motor's being disassembled to check the condition and the bearings, but mainly to machine the end bells. I need the long bolts to protrude from the shaft end bell enough to screw on a standoff to mount on a plate. So, and also they have to be flat, like it has to be a flat plane all the way around, and the casting is not flat. So I'm going to mount them in the milling machine and make everything coplanar, I guess you could say. just more measuring to the surface of the motor flange. The goal here is to cut the armature of the new motor as short as possible so that the motor is as low as possible on the mill. The mill's already quite high, and here I am extending the keyway in the shaft as much as I can, because I'm going to cut some of that shaft off later. Oops, there it is. I don't have a steady rest for the lathe, so I can't fit the armature onto the lathe. So we're going to do it the crude and effective method. Grind to the line. That's right. You see it, you know it.